Welcome everyone, I'm Brian Walsh, and in today's lesson, we're going over solution stoichiometry. So we covered general stoichiometry in a previous lesson. Now we're going to look at how to incorporate volume and concentration when we're dealing with solutions. So molarity is a unit of concentration, and it's abbreviated with this capital italicized M. And what it is moles of solute per 1 liter of solution. Remember that solute is the smaller amount of substance in a solution, and the solute dissolves into the solvent. The solvent is the larger amount of substance, and together the solute and the solvent make up the solution. So if we look at our little drawing over here, these little white particles are the solute because there's less of them, and the water that surrounds it is the solvent, and then together they make up the solution. If you're having a hard time remembering the difference between solute and solvent, there's a little trick you can use. So solute, the word, has 6 letters, and the word solvent has 7 letters. So solute is a smaller word, and it's also the smaller amount of substance. So this problem asks us, what is the molarity of an aqueous solution that contains 0.715 moles of glucose in 495 milliliters of solution? So we're going to start by looking at what information we've been given. So they told us that we have 0.715 moles of glucose and 495 milliliters of solution. So we can see that both of these things have only one unit, right? Moles is 1 unit, milliliters is 1 unit. And what that means is that they haven't given us any conversion factors. Now let's look at what they're asking us to find. So the question asks, what is the molarity of the solution? So that means what we're looking for is molarity. And anytime that you're dealing with molarity, it's a good idea to write it like this. So this way it's much easier to see. Molarity is moles of solute per 1 liter of solution. So when we look at it this way, we can see we've already been given our moles of solute, right? This 0.715 moles of glucose, that is our moles of solute. We've also been given a volume of solution, but our volume of solution has been given in milliliters, and we need it in liters. So what that tells us is we're going to have to convert milliliters to liters before we can calculate the molarity. So now we're going to set up our problem and solve. And the way we're going to set this up is we can look and see, we've already been given moles of solute here, so we're not worried about this part of the equation. What we need to do first, and before we can calculate this, we need to convert milliliters to liters. So we're going to convert this 495 milliliters to liters. So we start our calculation with 495 milliliters, and we put this over 1, just to make it a little easier to see how our units cancel. So we want to convert these milliliters to liters. We know that there are 1,000 milliliters per 1 liter, and we put milliliters on the bottom so they cancel with the milliliters on the top. And so what we do then is we cancel these milliliters with these milliliters, and what we're left with then is liters. And because liters is what we're looking for, now we can just go ahead and do this calculation. So we multiply 495 by 1 and then divide by 1,000. And what we get is 0.495 liters. So now we know the liters of solution, and we know the moles of solute, so now we can calculate molarity. So we divide 0.715 moles of glucose by 0.495 liters of solution. And what we get is a 1.44 molar solution of glucose. So as we've seen, molarity is a ratio of moles to liters. And what that allows us to do is that allows us to convert from liters to moles or from moles to liters. So in that way, molarity is similar to the molar mass because the molar mass allows us to convert from grams to moles or from moles to grams. It also serves a similar function as Avogadro's number, which allows us to convert from atoms or molecules to moles or moles to atoms or molecules. So this diagram shows you all the different ways to convert between units of the same substance. So this shows us how we can go from grams to moles, liters to moles, atoms to moles, or from moles to anything else. Only within the same substance, though. If we want to convert one of these things to units of a different substance, then we need the balanced equation. So we remember that the balanced equation gives us a molar ratio that allows us to convert from moles of one substance to moles of a different substance. But once we have moles of that new substance, we can use these same values to convert from moles of that substance to either atoms or molecules, liters, or grams of that substance. So you can use this diagram as a kind of roadmap to convert between any of these things. For example, if we want to convert from liters of one substance
to grams of a different substance, we would take our liters, use the molarity to convert from liters to moles of our original substance, then use the balanced equation to convert from moles of the original substance to moles of the new substance, and then we could use the molar mass of the new substance to convert from moles to grams. So this problem asks us to calculate the moles of solute in 14.56 liters of a 0.850 molar sodium chloride solution. So you can see that what we've been given is 14.56 liters of solution and 0.850 molar NaCl solution. So they've given us volume and concentration, and they've asked us to calculate the number of moles. So we're looking for moles of NaCl. So if we remember our diagram, we've been given liters, 14.56 liters. We've been given the molarity, the concentration. So we've been given this, and we've been given this. And they've asked us to find moles. So we're going to be going from here to here. So let's look at our given information a little bit more closely. They gave us 0.850 molar NaCl solution. Whenever you're given something like this, where it's written as molar with just the M, rewrite it like this. It's much easier to see what you're dealing with when you write it this way. So what we have is 0.850 moles of NaCl per 1 liter of solution. And we can see this tells us that we have 2 units, moles and liters, which means that this is a conversion factor. If we look at this up here, we have just 1 unit, just the liters, and that tells us this is where we're going to start our calculation. What we're trying to find in this problem is moles of NaCl, which tells us that our last step is going to be to convert liters to moles. So our last step, because we have moles here, we're going to need to cancel these liters. So this will be our last step, is to use this conversion factor. So we're going to set up and solve our problem, making sure that we set it up so our units cancel. We know that we're starting with 14.56 liters because there's just 1 unit. So we're going to need to cancel these liters, which means we're going to need liters on bottom here. And we want moles on top because this is what we're trying to find. So our concentration tells us that we have 0.850 moles of NaCl per 1 liter. We set it up so liters on bottom and liters on top will cancel. So this liter cancels, and we're left with moles of NaCl. Since moles of NaCl is what we're trying to find, we can go ahead and calculate. So we multiply 14.56 times 0.850, and what we get is 12.4 moles of NaCl.
If you have any questions about anything, or if you have any feedback that you'd like to give me, please leave me a message. You can leave a comment, or you can email me at chemistrymadeeasy118@gmail.com. Thanks for watching.